Seeking ways to tame the Colorado through the engineering skills of the Bureau of Reclamation. But with 7 states disputing how much of the river's water each could claim, construction of a dam, any dam, was only a dream. But in 1921, Secretary of Commerce Herbert Hoover joined representatives from the 7 states to seek out a solution to equal water rights. Hoover proposed to simply divide the area into a lower and upper basin and leave further negotiations to the states within those basins. This compromise paved the way for the Boulder Canyon project to be constructed. And in 1931, the structure that would one day bear Hoover's name began with an explosion. Not only of black powder and dynamite, but one of human tenacity and ingenuity. It was the largest single contract awarded to that time by the federal government. It took the combined resources of 6 companies, forged into a single contracting entity, to undertake the mammoth project. But before the first shovel of earth could be removed, the Colorado River had to be diverted from its timeless path. The key was to cut 2 tunnels through the canyon walls on each side of the river, each 56 feet in diameter and approximately 4,000 feet long. The 4 tunnels took 2 years to complete. With the tunnels open and cofferdams in place, the Colorado River had no choice but to leave its riverbed and flow through the man-made corridors. With the river diverted, steam shovels dug through as much as 135 feet of silt, mud, and gravel to reach bedrock. And there, Hoover Dam began as a simple square wooden form filled with concrete, followed by more than 3 million cubic yards of concrete over the next 2 years. Add the adjoining structures, and enough concrete was placed to build a 4-foot wide sidewalk around the Earth's equator. Heat from the setting concrete was predicted to take more than 100 years to cool, but engineers fashioned 1-inch steel pipe inside each concrete block before it was poured. A refrigeration plant so massive it could produce a 1,000-ton iceberg every day continuously pumped cold water through the pipes, cooling the concrete so construction was never interrupted. This innovative idea helped the entire structure be completed in just 5 years, 2 years ahead of schedule. Hoover Dam was built with 5 million barrels of cement, 18 million pounds of structural steel, 21 million pounds of gates and valves, and 840 miles of pipe. The scale of some of the equipment was beyond the capacity of American highways and railroads. The pipes that would carry water from the reservoir to the generators were so large they could not be shipped, so a manufacturing plant was created to build them at the site. An infrastructure of highways, railroad tracks, and power lines had to be created to move men and materials from outlying areas to the dam site and to supply electricity for construction. An entire town was needed to house the workers who were pouring in from all over America in the midst of the Great Depression. The project averaged 3,500 workers a day, working 3 shifts, 7 days a week with only 2 days off a year. The pay scale started at $4 a day, a good wage in the midst of the Great Depression sweeping America. Amid the country's economic uncertainty, the workers in this canyon gave new life to the nation's spirit, as they gave new life to the desert Southwest.
This is an engineering victory of the first order. Another great achievement of American resourcefulness, American skill, and American
Dam on
determination.
September 30th, 1935. In 1947, Congress officially named it Hoover Dam. Some call it the most prodigious engineering construction feat since the Great Pyramids of Egypt. When a U.S. Senate committee endorsed construction of Hoover Dam in 1928, its report said, "A mighty river, now a source of destruction, is to be curbed and put to work in the interests of society." And so it was. Hoover Dam brought the desert flood control, a reliable supply of water, electrical power, and more. Behind a 726-foot-tall concrete face lies Lake Mead, America's largest man-made lake. Born out of the collected waters of the Colorado River, it could cover the entire state of Pennsylvania to the depth of 1 foot. But held behind Hoover Dam, it is a life-giving source for communities throughout the Southwest. On its way to meet downstream needs, thousands of gallons of water per second flow from Lake Mead through the dam's 17 giant turbines, producing clean, non-polluting hydroelectric power with every touch of its coarse concrete skin and each sparkle that dances behind its crown. Hoover Dam reminds us of the need to dream noble purposes and the strength of the human spirit to achieve great aspirations.
And those people place 6.6 million tons of concrete on the dam. We have enough concrete here that we can make a sidewalk around the entire earth, around the equator, 4 feet wide, 3 inches thick with the amount of concrete placed there. So where you want to be in case of a big earthquake, right over here. Not in your house, the Bellagio, or Caesar's palace. Why? Because we should withstand an 8.6 earthquake. So the palace of my house, this is what comes behind. Welcome to Nevada power plant. Here we have 8 generators, and if you notice, there's a light on the top. If it's on, it is in operation. And most of the power goes to Southern California, mainly LA. Nevada gets 25%, and the remaining 10% goes to Arizona. In order to do all the heavy lifting and do all the maintenance work, we gotta have very good cranes, and we got 2 of them. What the flag is our first bridge crane. There's a second one at the end of the power plant. Each one of them is going to move along these tracks back and forth along the entire plant. Each one of them has a lifting capacity of 300 tons or 600,000 pounds. In other words, by using one crane, we can lift up 60 full-grown elephants at the same time, or the Statue of Liberty in New York City. Amazing. The crane from Wisconsin, 1930s, and they're still working with no computer and no iPhone. Take a look at N1, Nevada won the first generator. What you see is the top 30 feet. Then it's a 7 stories tall. When you go inside the exhibit area, your next stop, you can see a complete generator. Inside the rig casing are the magnets, and we call that a rotor. And today's a lucky day. About 4 months ago, we got both cranes together, and we pull out Nevada 6 and 6. It's right there on the floor. There are 40 electromagnets. They weigh 8,000 pounds a piece, and they must spin 180 times a minute. The shaft is 65 feet long, is in 3 sections, weighs 114 tons. At the bottom of the shaft is a water wheel. We call that a Francis-type turbine. Average weight around 70,000 pounds, and they last around 30 years. So the water comes from that pipe we're standing down below. It's going to hit the bottom of the shaft. at 40 miles an hour. We make the shaft spin, then we make the magnet spin, produce electricity. Then the water comes out behind to Lake Mojave and goes all the way down to Mexico. Then if you put two footballs close together, thickness of the wall at the bottom is 660